Hello everyone, welcome back to our YouTube channel. My name is Sania Sultana from Sri Venkateshwara College of Engineering. Firstly, let me introduce my group members Rachana HR and Shreya from 3rd Sem Chanukya section. Today we are going to explain about ALU with the priority queue scheduling and the linked list data structure. Let me start with the introduction to ALU and the data structures. It is a arithmetic logical unit. It is crucial component of a CPU that performs the arithmetic and logical operations. The data structure like the priority queue and the linked list helps to manage the data efficiently for the various component tasks. Understanding the integration of these concepts enhance the performance in the computational systems. Efficient use of data structure directly impact that the performance and the scalability of the software systems. Next, the overview of ALU functionality. ALU executes the fundamental operations including addition, subtraction and bitwise operations. It receives the input from the registers and the producers. Output can be used of the other CPU components. The efficiency of ALU significantly impact overall system performance and the speed. The modern ALU are optimized for the speed and they may also include support for the complex functions such as floating point, arithmetically vectors processing and the advanced CPU. This is a flowchart where it is an overview of the ALU functionality. Next comes the priority queue basics. Priority queue is an abstract data type that stores the elements based on the priority rather than the order of instructions. The elements with the high priority are proceed before those with the low priority, regardless of the insertion sequence. Instruction sequence. This structure is particularly useful in the scheduling tasks that require the urgent attention in the computing environment. Their performance depends on the chosen implementation and the specific requirements of the applications. NQs, back front, and DQs are the priority queue basics. Next comes implementing a queues. A priority queue can be implemented using the various data structures including the array, heaps, linked list and the list. In the linked list implementation, each node contains the data and a reference to the next node, facilitating the dynamic memory and the management. This allows the efficient insertion and the deletion based on the priority of the elements. The priority queue is the vital data structure for solving the real world problems that requires the dynamic ordering of the elements based on the priority.
So guys, next let us discuss the system architecture. The input module, priority queue scheduler, ALU, add, subtract and or etc. operations output module. So what is the input module? Input module means accepts data and instructions from external sources, prepares and forwards input to the scheduler. Priority queue scheduler organizes tasks or instructions based on priority, ensures optimized execution of operations by the ALU. Next, ALU. ALU means arithmetic logical unit. Perform arithmetic means and or subtract operations, logic operations means add or etc. operations, operates on the instructions forwarded by the scheduler. Next, fourth one, output module collects and forwards results from the ALU to the external systems or memory. Next, let us discuss one simple code. Hash include standard input output.h, hash include standard library.h, hash include string.h. First we have to enum for ALU operations. We have to take ALU operations, type, define, enum, add equals 1, subtract and or. These are the operations. Next we have to structure to store a task in the priority queue. Type defines struct task, int operand 1, then int operand 2. Next operation int priority, struct task task. Next we have to next new task operand 1, is equal to operand 1. New task operand 2 equals operand 2. New task operation is equal to operation. New task priority equals priority. New task next is equal to null. New task we have to return new task. Next we have to insert a task in the priority queue within the function. Void insert task, task head, comma task new task. If head will be null, head priority, new task priority. New task equals next is equal to head. Head is equal to new task else. Task current is equal to head. While current next is equal to null and current next priority equals new task priority. Current equals current next. New task next is equal to current next. Current next is equal to new task. Next, let us see the function to execute a task. Means we have to use ALU operations. ALU operations are AND, subtract, add, or etc. Int execute task, task, task. Switch task operation. First, we have to use case functions. Case add, return task operand 1 plus task operand 2. Case add means we have to add the operand 1 and operand 2. Next, case subtract, return task. We have to subtract operand 1 minus task operand 2. Next case and return task operand and task operand 2. Case or return task operand 1 or task operand 2. Default printf invalid operation means return 0. Next, let's see function to process the task queue means priority queue. While to process queue, task head, while head not is equal to null. Next, task current task is equal to head. Int result is equal to execute task current task. Print, we have to print the statement as executing task %d with priority %d result %d/n. Next, current task operand 1, current task operand 2, current task priority. Next, result. Head is equal to head next. Means remove the task from the queue. Next, we have to free the memory. Free current task. Int main task queue is equal to null means initialize the priority queue as empty. Null means we have to empty the priority queue. Next, example tasks. Task 1 is equal to create task 10, 5, add, 2. Task 2 is equal to create task 20, 4, subtract, 1. Task 3 is equal to create task 6, 3, and, 3. Task 4 is equal to create task 7, 2, or, 2. Head is equal to head next means we have to remove the task from the queue. Next, we have to free memory, free of current task. Int main task queue is equal to null means we have to initialize the priority queue as empty. Next, let's see the output of the program. Executing task 6, 3 with priority 3, result 2. Executing task 10, 5 with priority 2, result 15. Executing task 7, 2 with priority 2, result 7. Executing task 24 with priority.
Hello everyone, my name is Shreya. I am studying in Sri Venkateshwara College of Engineering. Advantages of using a priority queue with ALU. Integrating a priority queue with the ALU allows for efficient management of computation tasks based on the urgency. Tasks can be prioritized, ensuring that the critical operations are executed first. Optimizing system response time. This integration enhances overall computational efficiency, especially in real-time processing application. Linked list data structure. A linked list consists of a sequence of nodes where each node contains data and a pointer to the next node. Linked lists are dynamic in nature. allowing for efficient memory usage and flexible size adjustment. They are particularly advantageous for scenario where frequent is insertion and deletions are required. Linked lists are highly effective for applications requiring frequent insertion and deletion, but may not be the best choice for scenario demanding efficient random access. Real world applications. Priority queue are widely used in operating systems for task scheduling, ensuring efficient CPU utilization. They are also essential in network traffic management where packets are prioritized based on their importance. In databases, they are essential in network traffic management where packets are prioritized based on their importance. In databases, priority queues helps manage query execution based on the urgency of request, improving response times. Priority queues are the cornerstone in scenario requiring efficient priority based decision making, ensuring that critical tasks are that data are processed in timely manner. Challenges are considerations. Implementing priority queues requires a careful consideration of memory management, and performance overhead. The choice of data structure for the priority queue can significantly affect the efficiency of operations. Balancing priorities and maintaining optimal performance can be complex, requiring ongoing analysis and refinement. Conclusion and future directions. The integration of ALU with priority queue, scheduling, and linked list data structure offer significant advantages in computational efficiency. Ongoing advertisement in a hardware and algorithms design will further enhance these system capabilities. Future research will continue to explore innovative methods to optimize data handling and processing in the computing environments. Thank you.